This is exercise 7 on page 622, and in this exercise I'm given a little graph right here, and I have to finish the graph over the interval, in the interval -3 to +3, so in this interval right here, first if this is an even function, and then secondly finish the same graph if it's an odd function. So in red I'm going to add, if it's an even function, of course, I'm going to have y-axis symmetry. So every point that's on this side of the y-axis in x will be reflected on the other side. So this -1 at 1, -1 will be over here at -1, -1, and then I'll go up through 2 and up hit +1 up at -3. So sketching that in, this is the completion of the graph as an even function where I have y-axis symmetry, and this is, of course, where if I enter an opposite value, I get the original y value. So as an example, when I enter, if I start off and I say, well, f of 3 in this function of +3 is 1, then f of -3 should also be 1, and it is. So opposite input, same output, even function. Now, to make this an odd function, this is where I want to have origin symmetry in my graph. Okay, so I'm going to, this is like doing a 180 around on this -1 comes up here to be, where this is 1, -1, this will be up here, -1 at 1. Because with an odd function, when I put in an opposite value, I get an opposite result. So when I put in +1 for x and I get a -1, if I put in the opposite x value of -1, I should get a +1. So this graph goes up like so. And then whereas this turns then and goes up through 2, this will go down through 2, down to -1 at 3. So that would be the graph completing it if it's an even function, if it's an odd function, where you can see it has this y-axis symmetry. This origin symmetry, sorry. So for example, in this graph, f of 3, when x is 3, y is +1. And when I put in the opposite, I should get the opposite result. So when f of -3, so where f of 3 was 1, f of -3 is -1. So there's my, there it is, finished as an odd function. And that's it.